Okay, illustrative math, Algebra 2, Unit 3, Lesson 7 is called inequivalent equations. All right, so our goal is I can solve an equation by squaring or finding square roots. So what do you notice? What do you wonder? Pause the video and take a look at these and try to come up with some things that you notice and wonder. All right. So some notices. This equation here, you might notice that you can square root both sides, and we get, since we had to insert, we get x equals positive and negative 2. You might also notice that if I move the 4 over, you could now get this factored into x minus 2 times x plus 2, and you get the same answers. You might notice that you could graph this, and y equals x squared would look like that, and y equals negative 2 would look like that. So they never, so whoops, y equals 4, sorry. And that would move actually up here, y equals 4. So you could look at it on a graphing calculator type of thing, and your x coordinates would be at 2 and negative 2. Right there, something like that. Let's see here. You might try to square root both sides here. You might say, oh, shoot, I can't square root a negative. Well, you can. It's just going to be an imaginary number, but it's not going to give you a real number. So your answer is this one probably has no solution, no real solution, I guess. And if you go back to your graph here, if this is, y equals x squared right here, and negative 4, sorry, pardon my bad horizontal line, but they're never going to touch. You might notice that these are kind of the same here. I guess I kind of already did it. Over here, these are going to be x equals 2 and negative 2. And then this one here, if I want to get rid of the, actually, there's nothing else to do. A lot of people want to square both sides. I almost wanted to do that, but that's not necessary because x is by itself already. It's not a square root of x. So when I get here, the square root of 4 is just 2. It's just one answer, okay, because this is already given to us. So some have 2 solutions. This one has none. This one only has 1. And the first and third are actually the same exact equation. Okay, so a good little warm up there for us. All right, Tyler was solving this equation, x squared minus 1 equals 3. He said, I can add 1 to each side of the equation, and it doesn't change the equation. I get x squared equals 4. Priya said, it does change the equation, it just doesn't change the solutions. Then she showed these 2 graphs. How can you see the solution to x squared minus 1 equals 3 in figure A? So I guess this is figure A here. So your solution is going to be where they cross. Okay, so this graph here is y equals x squared minus 1. You see how my vertex dips down there? And this graph here is y equals 3. So my solutions here, if you look here, it's 2 and negative 2. All right, so then here, this is going to be y equals x squared, and this is going to be y equals 4. And you see here, the graphs look different because look at your vertex here. Everything's basically shifted up 1 unit, I guess. But here, my same solutions here, we get x equals 2 and negative 2. So use the graph to explain why the graphs have the same solution. So it's kind of like here. So here's this graph. It's kind of like I just translated everything up 1. And you notice everything vertically stays the same. So that's how we end up right there. Okay. So my answer here, I would say Figure B is a vertical translation up 1 unit. Since we do not move horizontally, the solutions stay the same. Okay. All right, Han is solving this equation right here, x plus 3 over 2 equals 4. He said, I know that half of x plus 3 is 4. So x plus 3 must be 8. Since half of 8 is 4, that means x is 5. Use Han's reasoning to solve this equation. So he's kind of mentally just plugging in numbers and kind of thinking it through, which is fine. It's definitely a good way to process what you're doing. But when things get a little complicated, you need a process. So I would say, okay, I'm taking some number and I'm squaring it and I get 4. So I'm thinking, okay, well, this has to be 2 because I square 2 and get 4, or it has to be -2. So here I'm going to say, oh, okay, well, if x is -1, I can plug in the -1. -1 plus 3 is 2. Square the 2, you get 4. But then this could also be -2. So the other option would be if it's -5, because -5 plus 3 would be -2. When we square that, you get 4. So kind of just like a trial and error type of thing. What advice would you give someone who was going to solve an equation like x plus 3 squared equals 4? I would say you're going to probably you could potentially need 2 solutions. Think of what number squared would give you 4, and the answer is, 2 or -2, I would say. So if you wanted to do this with algebra here, because this is algebra class, what I would do here is I would square root both sides. That gets rid of the squared. And what happens is we get x plus 3 equals, really it's positive and -2. So I'm going to do this. I'm going to make 2 equations since I have 2 answers there. And then, whoops. And then I'm just going to -3. And we get -5. Okay, so those are the same answers that we had. This was kind of just thinking about it. This is actually using algebra. Algebra is nice because it, when it's like not nice, pretty whole numbers, it works much better. All right, so take a look at your graph here. Here is y equals 4. And then this is y equals x plus 3 squared. And you can easily see that the answer here is -5 and -1. Okay. All right. Mai was solving this equation. She said I can square each side of the equation to get another equation with the same solutions. So basically, she did what we just did before and square both sides. That drops the square root. And then you add 1 to both sides, and she gets to 10. So check to see if her solution makes the original equation true. So what I'm going to do is I'm going to plug her answer in for x. So I'm going to replace the x with a 10 and see if the left side equals the right side. So 10 minus 1 is 9. And then the square root of 9 is 3. And sure, it checks out. So the answer is yes. Andre said, I tried your technique to solve square root of x minus 1 equals -3, but it didn't work. So let's do all the same algebra here. I'm going to square both sides. It gives me 9. and I get 10. So, but then I'm going to check it like I did on the last one. So it looks good. But the problem is when I go to check it, I get 10 minus 1 equals -3. Same idea. And then the square root of 9, we only want the positive. So that one, it does not work. So this would be a no. Okay. All right, so find the solutions to each of these equations or explain why there is no solution. T plus 4 equals 3. Let's square both sides to get rid of the square root. And I get t equals 5 for 1. And then I'm going to plug it back in. 5 plus 4 is 9. So square root of 9 equals 3. 3 equals 3. Check. You always want to check these. Let's go to number 2. -10 equals negative square root of a. So this is really kind of like a -1 here. So let's do this. Let's divide by -1. And then let's square both sides. So I get 100 equals a. And let's plug it back in. -10 equals negative square root of 100. Square root of 100 is 10. But there's a negative there. That works. It checks out. Let's try the third one over here. Let's add 4 to both sides. Let's square both sides. Let's minus the 3. And then let's divide by -1. And we get -13. Now I want to plug it back in and check it. So I'll come up here. 3 minus -13 ends up becoming a plus 13. This is 16. So this is 4 minus 4 is 0 equals 0. It checks out. Okay. Last one. Square root of z plus 9 equals 0. Move the 9 over to the right. Subtract it from both sides. Square both sides. I get z equals, let's put in parentheses there, z equals 81. But then when I check it, square root of 81 plus 9 should equal 0. But we're going to get a problem here. We're going to get 18 equals 0, which is not good. So this cancels out. So this one's going to be a no solution since my solution did not end up panning out for us. Okay. All right. So here's a problem here for the synthesis. 2 minus x squared equals 9. Square root both sides. 2 minus x equals, really it's positive and -3. So here's what I'm going to do. I'm going to make two equations. So -2 from both sides. Divide by -1. There we go. Divide by -1, and we get x equals 5. Okay. I want to plug them back in and check to make sure that they work. So if I plug in the -1, it's going to be 2 minus -1 is +1. I get 3 squared, 9 equals 9. That worked. If I plug in the 5, it's going to be 2 minus 5 squared equals 9. So this becomes -3. Make sure you keep the parentheses there. -3 squared. That works. Okay, good. Do these have the same solutions? I would say no. I would say this one has no solution because the square root equal to a negative number. This one's going to be no solution. This is going to actually have one solution. You're going to minus 2 and then divide by -1. You're going to get -7. Whereas here, if I plugged in -7, it doesn't really make any sense because I'd get 2 minus -7 becomes plus. So square root of 9 equals -3. So 3 is not equal to -3. So you can clearly see that they're not the same. So the answer here is no. Here's my work to explain it. So I can solve equations by squaring or finding square roots. I think so. Find the solution to each of these equations or explain why there's no solution. So for the first one, I'm going to square both sides. And I get 23. Okay, you want to check it, make sure that it works. 23 plus 2 equals 5. That'd be 25. 5 equals 5. It works. Okay, let's go here for the second one. I'll tell you what, I'll just come right here and square both sides. So I get y minus 8 equals 1. I already kind of have a hunch that a square root equal to a negative is probably not going to work, but I'm going to do it and show my work just in case I didn't notice it off the top. So I get 9, but then I want to check it. 9 minus 8 equals -1. Square root of 1. 1 is not equal to -1, so this is no good. Throw that out. So now I have no solution. Okay. All right. I hope you enjoyed this lesson video. Thank you for watching.